So we prepared 4 different videos for you on operations with fractions. The first video is addition with a little bit of introduction on some of the prerequisite skills you might need. And then we do, for each of the other operations, we expose you to analyzing the word problem, looking at the area model, looking at the Cuisenaire rod model, and then we develop the paper and pencil algorithm that comes after that. The real point of this is that you be able to view the videos and pause and review them until you get very comfortable with what those operations look like and what the word problem structure is like. Okay, so now we're going to look at subtraction, and we'll start with this word problem. It's just, again, an example word problem. It's very simple. We'll do more complex ones later.
You did get your head in just slightly, that very first sentence.
Okay, so you're going to start over?
I'm just going to keep the camera rolling.
So just start over?
You can just start over where you like, or put the cover back on the subtraction.
Yeah, I don't know if I need that. Okay, so, all right. So we're going to start with subtraction. Here's our sample word problem. It's a very simple one, but we'll do more complex ones later. So the situation is Julie has 2/3 of a whole cup of milk in the refrigerator. She uses a half of a whole cup of milk to make cookies because that's what the recipe called for. And what we want to know is how much of a whole cup of milk is left. So there's a couple things about this subtraction that we want to talk about. We'll later compare this with multiplication. For some reason, people tend to confuse subtraction and multiplication. So we'll try to talk about what makes this problem special, that makes it a subtraction. The key here is that subtraction requires a portion of the whole. So notice here we're doing half of a whole cup of milk. And we want to know always how much of a whole cup of milk is left. If you will think recipes on this, it maybe will help you as you're writing your own subtraction problems, that recipes always tell you to use half of a whole cup or a fourth of a cup or something like that. They never say go to the refrigerator and use half of all the milk that you find in there, which is what's going to happen when we do multiplication. Also, this is a takeaway. We're going to model takeaway just to keep it simpler. Comparison and missing add-in will be similar, but we're just going to focus on takeaway. Okay, so let's start by doing an area model. So again, we're back to making sure we have a picture of what the whole thing looks like. And I know this doesn't look like a whole cup of milk, but we're doing semi-abstract kind of modeling of what's going on here. There's the whole cup of milk. What we know is that Julie has 2/3 of a whole cup. So Julie has enough milk. We have to divide this into thirds. She does not have any milk out here. This is all the milk she has in here. And so for subtraction, it's really, really helpful. Let me do this with the black one. That we note that we do not have any milk out here at all. So we're not tempted later to pull milk from that area because there's no milk there. Okay, so there's the amount of milk that Julie has in the refrigerator. Don't know how we know that, but that's what we know. She uses a half of a whole cup to make cookies, so we need to know what half of a cup looks like. So use a different color, shade the other direction. Here's what half looks like. Notice again, half is 3 pieces because the green subdivision is divided into 2 equal pieces, so 3 of those make up a half. So if we're going to use a half a cup in the recipe, we need to remove a half a cup from what's there. So notice a half a cup is 3 pieces, but I can't take it from here, so I'm going to take the 3 pieces from this area right here and actually show it being removed. And then what you want to do at the end is answer the question, which is how much of a whole cup is left? Well, there's 1 piece left right here. So what's the part that's left? 1 piece, but how big are those pieces? Those are 1/6 of the whole. Later on, we'll be a little bit more careful with this. We might get to some more complex fractions. If we have to subtract 2/3 of something, then we got to shade each of the thirds and show them all being removed. But for now, we're just doing it in a very simple way. Okay, so let's move on to Cuisenaire rod model. Again, we need to know we need to make a wall just like we did before. So we need to know what the whole looks like. We need to see what thirds look like and what halves look like. And it doesn't matter the order here. You can do the thirds on top or the halves on top. It doesn't really matter. I tend to always put my whole at the very top. And we always want to stack up single blocks at the beginning. So that's the wall. And again, it's there so I can know what wholes, what thirds, and what halves look like. Because then all I have to do is go back to the original problem and model it. It says Julie has 2/3 of a whole cup. So since the reds represent thirds, that's what 2/3 look like. She uses a half of a whole cup, so she's going to use this much. Now, I could model up here and show it covering up that way, showing I'm using a half of a whole cup. The problem is if you have to draw it later, you can't draw one rod on top of the other one. So we're going to model it like a linear model again. And so what we're really thinking here is that from this point to this point, like in a linear model, is 1/3, 2/3 total, all the milk that was there. And then from here to here represents how much of that I've used. That's the half of a whole cup that's being used. And you want to know how much is left. So we always just go back and measure, and we can see there's one little block that's left over. So I know the answer is one block. So you refer back to the wall again to see how much is that block. Well, that block is 1/6 of the whole. So this is 1/6 left. And it's always of a whole cup. 1/6 of the whole cup is left. Okay, so let's look at what paper and pencil algorithm might look like on this. So the original problem was that we have 2/3 and we're going to remove a half. And we want to know how much is left. Well, notice back in the Cuisenaire rod model, 2/3 here, these two red blocks, really became, if you look at them in the wall, that was really the same as 4/6. So we're getting equivalent fractions. It's one of the basic ideas here at the beginning is that you've got to be able to convert these to equivalent fractions. That's really 4/6. And 1/2, which is the green or the lime rod, is really 3/6. And so when we actually think about what we've done here, we actually have gotten common denominators again. 2/3 became 4/6, and we're subtracting 1/2, which was 3/6. And so again, we've converted a fraction problem to really a whole number problem. When we get common denominators, it's really about like 4 apples take away 3 apples is 1 apple. So 4/6 take away 3/6 is 1/6. Now let me just compare that to the area model so you can see the same thing happened with the area model. Notice 2/3, which were the red marks here, was 1, 2, 3, 4, 6. And 1/2, which was the lime markings, that's a half is 3 pieces, so that's 3/6. So I remove 3/6 and I count to see how much is left. So again, common denominators make sense on subtraction and addition because that algorithm does actually match what you do at a concrete level. So we don't have to do any adjustments on that algorithm. So you've just seen some videos on operations with fractions. Your task now is to go to Blackboard, look at the instructions there, follow the instructions. Typically what you're going to do is come to class prepared with 2 word problems for each of the problem types, each of the operations, with Cuisenaire rod model, with area models drawn, with paper and pencil algorithms. If you have trouble doing it, you can always go back and review the videos and use that as a guide.